Welcome back. In this submodule, we're going to talk about how to use functions to describe mathematical and physical relationships. The idea is that we know that a function is something that takes something as an input, performs some sort of operation on it, and gives you an output. There are many ways to interpret interesting inputs and outputs in the real world and theoretical science and mathematics. So just to give you some examples, I can think of my input being, say, the radius of a circle, and the output being its, say, area. So I can define a function a of r, which will take the radius of a circle as its input and output its area as a function of the radius. So this is another way of sort of saying, is there a formula for the area of a circle given its radius? Well, let's draw the picture, see if that helps us out. So I can think of a circle here, and this distance is its radius. Maybe you remember that the formula for the area of a circle is in fact almost always given as a function of the radius, and it says what I need to do is square the radius and then multiply by a special constant, multiply by the constant pi. So this is one just very basic example of using the idea of functions to model relationships. Here I've explicitly made the area of the circle as a function of the radius. We can do this for other geometric quantities as well. So another example, we can look at a rectangle. So my input will be the length and width of a rectangle. And again, I want to make the output some geometric quantity based on those. So let's again look at the area. So I want a function a of, now it's not going to depend just on the radius. There is no radius here. There's the length L and the height h, and the area should somehow depend on L and h. So if we draw a picture, length, height, so I guess in this case I can say that width is the same as height, but just to be consistent with my notation, I'll call this W, not H, but they mean the same thing. Okay, so I'm looking at this. Maybe you recall that if I want to compute the area of this, it's L times W, length times width, so just LW. So the function says, take as an input L and W and output the product of L and W. And again, we can interpret this in a geometric way as giving a formula for the area of a rectangle. In general, functions can be used for many more complicated notions than this, but I think that these are nice examples that you probably have seen at some point and then can interpret in the language of functions. So we'll look next at particular types of functional modeling. We'll look at modeling with linear functions and then also with exponential functions.